This tutorial will go over basic operation of spMats by covering example 1 from the manual. The problem formulation is a 10 foot by 10 foot by 2 foot footing is presented in John F. Bull's Foundation Analysis and Design. A 500 kip load is applied at the center of the footing. To begin, we'll prepare our input. From the Define menu, choose General Info. For the project name, we're going to use example 1, and for the description, we'll use spMats manual. For the engineering parameters, we're going to use English units, and for the code, we're going to say ACI 318-14. Alright, now we're going to go to the grid by choosing the Grid tab. And we get a warning telling us that we changed the code selection, and we just need to verify the load combinations. So choose OK. Alright, for the grid, we're going to go to the right and choose Generate and double click. Okay, so we're going to want, in the X direction, we want 0 for the from distance. For the number of grids, we want 6. And for the grid spacing, we want 2. And we want the same in the Y direction. So 0, 6, and 2. Choose Generate. Alright, now we can go back to the Define menu and choose Thickness. For the label, we're just going to use Thick 1. And for the thickness, we're going to choose 24 inches. Select Add. And next up, we're going to go Soil. We can go over here to the List item and go to Soil. For the label, we'll use Soil 1. For the subgrade modulus, we will want 100 kcf, and for the allowable pressure, we want 6 ksf, and choose Add. Alright, so over to the list area, and we can choose Concrete, and for the label, we'll put Concrete 1. For the compressive strength, we want 3 ksi. For the unit weight, we want 148 pcf. For Young's modulus, we want 3,245. And for Poisson's ratio, we want 0.15. Choose Add. Okay, over to the item list area and choose Reinforcement. For the label, we'll use Steel 1. For the yield strength, we're going to put 60 ksi. For Young's modulus, we'll use 29,000. And choose Add. Alright, to the item listing area, we'll choose Design Parameters. For the label, we'll put DC1. For the minimum reinforcement ratio, we want 0.09%. For the X direction, we want 3.25. The Y direction, we want 3.75. And we want the same for the bottom layer in the X and the Y direction. And then choose Add. Okay, next we'll go to the Define menu and choose Load Combinations. Alright, over to the item listing area and choose Service. Then click on the Insert button. And for case A, we're going to input 1.0. Press Enter. And then back over to the item listing area and choose Ultimate. And then choose Insert. And for case A, we're going to choose 1.0 and press Enter. And we're going to uncheck Include Self-Weight in case A for all combinations. Next, we're going to go to the Loads tab and select Concentrated in the item listing area. And then choose Insert. And for case A, we're going to choose -125 for PZ. Alright, next we're going to go to Assigning Properties, and we're going to start by going to the Assign menu and choosing Thickness. And then in the List item area, we're going to choose Thick 1. And now we're going to Marquee select the whole grid. So we're going to go start over here and select everything. Alright, next we're going to go to Soil and choose Soil 1. And we're going to apply it to everything again. So Marquee select the whole grid. Alright, next we're going to choose Concrete and Concrete 1. And again, select the whole grid. And then Reinforcement, Steel 1, and select the whole grid. And design parameters, DC1, and Marquee select the whole grid. Alright, now from the assign menu, we can go to nodal loads. In the item listing area, we can expand case A and select P1, and we want to click on 4 nodes. We want to go to 4, 4, 6, 4, 6, 6, and 4, 6. Alright, now we're ready to solve. Let's go to the solve menu and choose execute. And we're just going to run the solver with default options. So here we can just select run. Alright, we just have to save it, so we'll just save it as spMats example 1. spMats provides us with many different contour views, including the area of steel required, ASX, from the top and from the bottom, as well as ASY, from the top and from the bottom. It also provides service load contours in the displacement, as well as soil pressure.